Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, I will take you through the complete configuration of a common network topology with dual ISPs and VLAN segmentation. We are going to configure many protocols in this topology. So if you are a fresher in networking industry or you are an experienced one and want to refresh your knowledge, then this video is only for you. Make sure you will watch this video till the end. In this video, I'm going to tell you a step-by-step configuration to live this network. To live this network means at the end, all end machines will be able to access internet and will be able to access remote site resources, as well as outside user will be able to access my internal resources. My internal resources means, as you can see, I have one server in the internal network. So that server should be accessible from outside, from the internet as well, and from the remote side as well. Done. But guys, before starting the configuration, let me tell you about this topology, more about this topology, like why we have two ISPs, for which type of company this network is suitable, and definitely we'll talk about the improvement, right? At the end of this video, I will tell you the recommendation, my recommendation within my experience and knowledge. I will tell you where you should work for the improvement, right? Like there is no redundancy at core layer, no redundancy at distribution layer, there is no firewall for the security, right? So how you can secure this network. Done. So guys, see here we have two ISP. So we'll see the dual ISP configuration, like either I can configure primary and secondary, or I can distribute the traffic, like I can forward critical traffic towards ISP1 and the general traffic towards ISP2, means we can achieve the load balancing. After that, we'll see the SVI configuration on switch, as this switch is my gateway. Then VLANs, inter-VLAN routing, right? We'll see the port security on the access layer switches, right? The remote access to the internal server, like a static NAT, or we'll configure the BGP here, right? We'll purchase a IP block, public IP block, right? We'll purchase the ESN from the RIR, right? And after that, we'll see how outside user can access the internal server. Then guys, we'll configure the switch port analyzer, right? How to analyze the port of switch, like this port, whatever traffic it is forwarding or receiving on the port, I want one copy of that traffic on this server, let's say, right? So we'll see the switch port analyzer. We'll see the syslog configuration, how to save the log of all devices, all networking devices on the server, right? Then how to set up the DHCP so that end devices can get IP address from the DHCP server. We'll see the VLAN hopping. This is again a part of security, right? How to configure the VLAN hopping, right? Failover between ISP1 and ISP2. Primary and secondary scenario with the help of BGP. After that, NAT translation on edge router so that my general employees can access internet. We'll configure the default route, right? We'll see the MAC address table. We'll see the trunk encapsulation protocol and many more things, right? So now guys, without wasting our time, let's begin. See, this topology is, guys, there is nothing in this topology, right? Configuration is 0. So we are going to perform configuration from scratch, from the 0. First, we'll do the IP configuration, right, on all the devices. After that, we'll set up the DHCP, right, so that end devices can get IP address. After that, we'll configure the gateway, this switch, so that these two VLAN can communicate with each other. After that, we'll configure the routing between R1 and distribution layer switch, like internal routing. Then we'll configure the edge router, right? After that, we'll see the configuration between edge router and ISP. See, if you are going to run BGP here, BGP protocol between ISP and edge router, you need two things, right? First, ESN, autonomous system number. So if you don't have idea about ASN, first of all let me clear it. And before talking about the ASN guys, you know, this network is best designed for the small offices, right? For the small offices, you can say for the medium sized companies or for the branch office, right? Let's say there is one organization, XYZ organization, and this organization have multiple branch offices, and he is going to add one new branch somewhere, right, at different location. So this design is the best for the branch office, right? Definitely they can use one firewall for the security, they can add one more switch here for the redundancy, because we don't have redundancy over here. So if this link will goes down, right, or this link will goes down there, then there will be some problem, right? But guys, this is most common hierarchical architecture, right? You can say this is a common architecture layout, right, with 3-layer architecture model, right? We have 3 layer here. You can see core layer, distribution layer, and access layer. So this is 3-layer architecture model, right? Generally used in the small to medium size company or for the branch offices, where R1 is going to handle WAN traffic, or you can say internet bound traffic. R1 is going to manage internet bound traffic, as well as it is going to manage remote site traffic. Let's say like this, I have one another site somewhere, R1, then switches like this, and this is also connected with 2 ISP, correct? ISP 1, ISP 2, and as you know, all ISPs are directly connected with each other. All the ISPs are directly connected with each other. So here we need to configure the tunnel between these two sites. Both are my site, right? My company. This is one side, site 2, let's say site 2, and this is site 1. Site 1. So this router, my R1, is going to manage traffic of this side as well, remote side. Okay. So R1 is going to handle WAN traffic, or you can say internet bound traffic. Also involved in remote connectivity, like in the VPN, right? Or guys, it is also responsible for the cloud services. Let's say I have some application on the cloud on AWS, right? So I am going to access those resources as well through internet only, correct? So R1 is going to manage those traffic as well. And this is not sure that every time we are going to use internet only here, right? It can be internet, it can be your MPLS, it can be broadband, any service provider connection. Fine. So R1 is going to manage multiple types of traffic. Then guys, this is the gateway. Gateway device is going to manage the internal traffic as well as external traffic, right? It is responsible for routing between the VLANs, and it is connecting your access layer to the core layer. So that's why we are saying this is a 3-layer architecture model. Fine. And after that we have some access layer switches. Here we'll perform the internal routing, like we'll create the VLAN, we'll create the SVIs, like switch virtual interface. And you can see for both VLAN we are using different subnets, right? And now again we can divide this subnet. Let's say this company have 2 floors. This switch is at first floor, this switch is at second floor. And guys, at each floor we have different types of traffic, like HR traffic is there, right? Voice traffic is there, data traffic is there. So what we can do, we can perform subnetting on this subnetting, right? And after that we can divide it into again further part. Then guys, you know, after watching this complete video, you will be able to design and configure a network for a small to medium sized company or for a branch offices. Now we were talking about the ESN. So let me discuss ESN, how you will get the ESN. So see, first of all, to get the ESN, two things is required by the way. For the companies, let's say in my internal network I have some servers, right? Like mail server, this is mail server, this is web server, right? Like this we can have multiple server. So let's suppose we are hosting multiple services here, and we want to provide a remote access, means user from the internet or from the MPLS, like from the remote side, should be able to access these resources. So we have two options. Either here I can configure the static net, but I have to configure a static net for each the server or for each services. Like in the virtualization, on a single server we can run multiple machines, that is VM, right? And each VM will have one IP address, and for all the IP address we have to configure a static net, right? And as you have two ISP, let's suppose here is my server and this server IP address is 192.168.2.1 for an example. Fine. So here you have configured the static net. How many static net you need to configure? Two. One for ISP1, one for ISP2. One for ISP1, ISP2. Because let's say the public IP address of this server is 1.1.1.1 via ISP1. Means outside user from the internet can access your internal server with the help of this IP 1.1.1 via ISP1. In the same way, you have to use another public IP address 2.2.2.2, let's say, via ISP2. Means outside user will access your server, internal server, with the help of public IP address via ISP2, and that public IP address is 2.2.2.2. Now question is, let's suppose there is someone on the internet. How they will get to know I need to use 1.1.1.1 or 2.2.2.2 to access the server? So you have to configure DNS failover here. DNS failover. And you know, DNS failover, there will be some latency in DNS failover because of cache, right? So that's why most of the time company is not preferring DNS failover. Companies are using BGP protocol over here, right? BGP for the internal server access. And to run the BGP you need two things. One is IP block and the second one is ESN, right? And guys, these both things you can purchase from RIR. RIR stands for Regional Internet Registry. Regional, R for regional, I for internet, and the last R is registry, right? So you have to find the RIR first in your country, right? Like I am sitting in India. So my RIR is APNIC. My RIR is APNIC. APNIC stands for Asia Pacific Network Information Center, right? Asia Pacific Network Information Center. So first you have to find what? RIR. Let's say you have find the RIR, your RIR is APNIC, sorry, right? Now I am going to request for the ESN to APNIC. How? Simply I will go to their website, their official website, apnic.net. Let me show you the website as well here. apnic.net is the website. Yes, this one, right? Here I can request for ESN. So again, to request for ESN, I have to share my requirement. Like I have to share my topology that I am using multi-home, right? Multi-home means I have connectivity from multiple ISP, more than one. So I have to share the topology, I have to share my requirement, and after that you will request for the ESN, right? So you have applied, you have submitted one application for the ESN to your RIR. RIR means Regional Internet Registry, and my RIR is APNIC. So they will review it, and after that they will allocate one ESN, right? They will allocate one ASN. Let's say they have allocated one ASN 65001, right? This is my ES number for the BGP, correct? Now guys, I have ESN, ES number, autonomous system number. I can configure the BGP on R1. They will also share their ASN, like what ASN number they are going to configure on internet router. Let's say they are using 655.65001, right? So they will configure BGP peering on their router, right? They will run command router BGP 65001 neighbor and your public IP address. So the next thing which you need to purchase is IP block. IP block means the public IP address. Let's say I have purchased one public IP address with /24. So how many valid IP addresses are there, guys? In this subnet, 254. I need 2 over here. I need 2 over here, and the rest all I can use for my internal servers. Getting my point, right? So whatever IP address I am running over here, with that IP address, ISP is going to form BGP neighborship. And once you will configure BGP on your edge router, BGP peering will come up. And after that, we can share the public network, this /24, right? Once we will advertise that /24 public subnet to the internet router, automatically that subnet will become reachable from the internet. That means anyone from the internet can access my server with the help of public IP address directly. Then NAT is not required, right? Then guys, we are performing routing directly, right, with the help of BGP. So most of the time we are using BGP over here only, right? We are not configuring the static net. Static nets are good for the very small company like your home network, right? In my home network, still I am using a static IP address, right? I have purchased from my local ISP. But for the companies, if their design is multi-home, they are using BGP. So here I can use the BGP, and definitely I will use BGP. We'll use the NAT as well. We'll configure NAT, network address translator, for the general users so that these users can access internet. Done. So hope topology is clear, guys. Like what we are going to configure is clear. Okay, that's why I am telling you that after watching the complete video, you can configure the network for a small company. Now, without wasting time, let's begin. First of all, let me configure IP on ISP router. I'm going to access ISP1 first. And on the ISP router, we are only going to configure IP addresses for now. Interface F0/0, no set. And let's say between ISP1 and ISP2, my subnet is, let me do one thing. Let me here, I'm going to delete this one because it is not required. By the way, it's better to have, yeah. Let's say my public subnet is 100.1.1.0/24. Correct, guys? So what I can do here, see, total number of valid IP addresses in this subnet is 254. I need some IP addresses on this WAN link, some IP address on this WAN link, and rest I will use in the internal network. So I can divide this network into multiple parts with the help of subnetting, right? So if I will use, guys, /20, let's say 6, that means I have divided it into 4 parts. If I will use /27, that means I have divided it into 8 parts. If I am using /28, that means I have divided it into 16 parts. So that is fine. /16 networks. I'm going to divide it into 16 network, and later I will use it, right, according to our requirement. But for now, I will use one subnet over here, one subnet over here, right? So you know the subnetting, how to perform subnetting. For /20, subnet mask for /28 is going to be 255.255.255.255 255.240, right? So you can find the total number of valid IP addresses in the subnet. So let me write here, this is my main public subnet, and I'm going to use two network for now. So one network is 100.1.1.0/28, means my subnet mask is going to be, guys, my subnet mask will be 255.255.255.240, correct? The second subnet will be 100.1.1. See, now you need what? Block size. How to find block size? 256 minus subnet mask of last octet, means 16 is the block size here. So next network will be .16/28, right? Here also subnet mask is going to be same, 255.255.255.240, correct? In both subnet, how many IP addresses are there? In both subnet, 14 valid IP addresses are there, correct? So I am going to use first subnet between WAN is router and the ISP, which is 100.1.1.0/28. I will use here, and 100.1.1.1.1.16 between WAN is router and ISP 2. So now it's clear. Let me configure the IP now on ISP. So I have run no such command, say IP address, and guys, second IP address I am going to configure on ISP router, or let's say last IP address. So last IP address will be what? 14. See, the last IP address of this subnet will be 100.1.1.15, but that is broadcast ID. So second last IP address is the valid IP address, which is 100.1.1.14, correct? Then 255.255.255.240. So I have configured last IP address from the subnet on internet router, and I will configure first IP address from the subnet on my edge router. Then second interface, sorry, loopback 1, I'm going to create one loopback for 8.8.8. Let's say this is server on internet. So for now I have configured the ISP router. Let me minimize it. Let me access ISP2. And on ISP2 also we are going to do same thing. Configure T, interface F0/0, say no set, and the IP address 100.1.1. Now what will be the last IP address of this subnet? See, next network will be .32, means last IP address of this subnet will be .31, and last valid IP address will be .30. So say 30. 255.255.240, done. Then I need to create one loopback, interface loopback 1, IP address 8.8.8.8, 255.255.255.255, let's say. Right, now let me save the ISP configuration, ISP1. Let me save ISP2 configuration as well, ISP2. Now for now I can close the console of ISP, because we are not going to configure anything for now. Done. ISP router configuration is done. Now guys, for these end devices we need what? DHCP. So I have two VLAN. For both VLAN I am going to configure DHCP here, right? So let me enable DHCP service here first. To enable DHCP service, this is Cisco iOS device, right? So if you know how to configure DHCP on Cisco iOS, you can configure it. Let me access this device here, say no to this. Yeah, enable config T, host name is server, done. And to enable DHCP, first we need one IP address over here, correct? So interface F0/0, say no set, and guys, IP address, let's say I'm going to configure IP here 192.168.2. because this is in VLAN 20, and for VLAN 20 I am using this subnet, right? For VLAN 10 we are using this subnet 192.168.1.0/24. VLAN 20 I am using 2.0/24. So from this subnet I am going to configure one IP address, correct? We'll use last IP address from both subnets as a gateway, so we'll configure that on switch. Here let me use .100, let's say 255.255.255.0. done. I have used .100 here to the server. So you will always configure a static IP address on server. Let me define the IP here. IP address of this server is .100. It will be easier, correct? Now I need to create two pool, one for VLAN 10 and one for VLAN 20. So say IP DHCP pool, and pool name is, guys, let's say VLAN 10, and here I am going to say network. For VLAN 10, network ID is 192.168.1.0.255.255.255.0, and then default router. Default gateway IP address, as I told you, the last IP address of the subnet will be the default gateway IP address, which I will configure on switch, distribution layer switch. So 192.168.1.254 is my gateway IP address. Then I can define the DNS server IP address, let's say 8.8.8. If you have TFTP, you can define the TFTP server IP address. Done. If you have multiple DNS server, you can define the multiple DNS server IP addresses. Then I need one more pool, IP DHCP pool, and say VLAN 20. Here I am saying network 192.168.20.255.255.255.0. done. And the default gateway IP address is 192.168.2.254, and the DNS server IP 8.8.8.8. So DNS configuration is done, sorry, DHCP configuration is done over here. So IP DHCP pool, you can verify it, right? So guys, we have two pool, one with name VLAN 10, right, where you can see the total number of IP addresses are 254, and the range is this one, right? And another pool is VLAN 20. Again, in this pool we have 254 IP address, and so IP DHCP binding. So there is no any binding till now. That means this DHCP server didn't assigned any IP address to any machine till now. Done. DHCP setup is done. Now let's configure the VLAN, right? Let's start the configuration from access layer switch 1, right? First of all, we'll do the configuration of access layer switches, then access layer switch 2, and after that distribution layer switch. So here I have access of access layer switch 1. Now guys, on this access layer switch we are going to configure multiple things, right? Config T, first of all, host name is switch 1. Then see, the LAN interfaces should be in VLAN 10. So interface range E0/1 to 2. I'm saying switch port access VLAN 10, and before that you can run command switch port mode access. First you can make this port as access port, and after that you can put it in VLAN. So switch port access VLAN, let's say 10. So VLAN 10 was not there, so that's why it's creating. Done. Now you can see do so VLAN. So here we have do so VLAN brief. So here we have VLAN 10, guys, one VLAN. This is the default name. Even we can change the name of the VLAN, and then we have two interfaces in this VLAN, right? If you want to change the name of VLAN, you can say VLAN 10, and then name I can say, let's say admin, right? Or I can say the HR, anything like this. Now do so VLAN brief. So you can see the VLAN name is changed now, correct? Now we need to configure this port E0/0 as trunk because it is connected with another switch. So interface E0/0. Then switch port trunk encapsulation protocol. First of all, we have to define the encapsulation protocol, and I am going to use .1q. Nowadays we are using .1q, right? We have one more protocol here, that is ISL. Even you can put the question mark here. You can see you have three options. One is .1q, which is the open standard protocol. Second one is ISL, which is a Cisco proprietary protocol, and the third one is negotiation, means we can tell to negotiate the encapsulation protocol, so it will start negotiating from their neighbor device. But here manually I am going to configure .1q, and after that switch port, mode, trunk. So I have configured the trunk port. Now guys, we need to configure port security here. See, I am configuring whatever things I am configuring. Let me write here, it will be easier. First, I have configured the VLAN. VLAN is done, VLAN configuration. Then port assignment is also done, assigned to VLAN. Then I have configured the trunk, encapsulation, and trunking, both is done. Then now I am going to configure port security, right, to secure the port. So again, let me take you here and say interface range E0/1 to 2. To enable port security, you will run command switch port security. Then guys, switch port security, and maximum MAC address. How many MAC address it can learn on one port? Let me allow only one MAC address, because all ports are connected with PC only, right? If port is connected with, let's say, multiple devices, then definitely you have to allow more than one MAC address. Let's say one port can be connected with your IP phone as well as the PC. In that scenario, you have to configure maximum port 2, right? And guys, to configure the voice VLAN, you can run command switch port voice VLAN, and after that VLAN ID. So let's say VLAN 100 is my voice VLAN, so I can say VLAN 100 like this. For now, I'm configuring switch port security, so I have allow only one MAC address here. Then again say switch port security. After that, how it will learn the MAC address? So I am saying ST key, means it will learn dynamically. After that, what action it will take if it will receive unauthorized frame? So violation can be protected, violation can be restrict, and violation can be shut down. So I am going to use protected. So whenever it will receive unauthorized frame, it is going to drop the traffic. But as I have server guys, log server, I can use restricted option as well. Done. So the port security configuration is also done. Now if you want to change the MAC addressing time, you can run command MAC address table, and then for VLAN MAC address table, and then we can say aging time for VLAN, aging time, let's say 100, for VLAN 10. So for a specific VLAN, I have changed the MAC aging time, and this switch is going to handle only VLAN 10 traffic. Done. But in your network, VLAN 20 is also there, right? So sometimes this switch will receive traffic of VLAN 20 as well. So guys, VLAN 20 should be there in the VLAN database, right? There will be no any port in VLAN 20, but you have to create the VLAN 20. Otherwise, ping will not work. Later I will show you. After that, I will configure it. That is part of troubleshooting. So here on access layer switch 1, I have configured the port security. Now let me configure the S pane here, right? Switch port analyzer. Like I want to monitor this switch port, all ports of switch. I want to monitor all ports of switches. For that, what I will do, I will configure switch port analyzer. And to configure switch port analyzer, guys, we need to run some commands here again. So say not a spanning tree, yeah, a spanning tree command is also required. Monitor, and then we can say session, monitor session number, monitor, and here on the interface why I'm not able to run command monitor, and only event trace option is there. There should be one more option, that should be, just wait, interface. I'm going to use the range command, this one, and say monitor. Okay, I'm not able to run this command, right? But we'll see it later, right? We can say monitor. I will try it on the distribution layer switch. Then we can say session, and then session ID, let's say 2 or 10. And after that we can define the source port, like what port you want to monitor, and then interface destination port, like on which port it will send the log message. Once you will apply this command, what will happen here? What I want, this server is for monitoring now, right? So I want to monitor this port, analyze this port. Whatever traffic will be received or transmit on this port, it will send one copy of that traffic to the destination port. So destination port can be my server, right? If the log server allocated a different switch, right, then you have to configure remote span. So there are two types of actually span stands for switch port analyzer, right? Switch port analyzer is used to analyze the port of switch, right, like to monitor the incoming and outgoing traffic of a port, of a switch port. And there are two types of span. One is local span and another one is remote span, right? Local span means, guys, if source and destination both belongs to same switch. Let's say this is my switch connected with router, right, and here I have PCs, and then I have one server here where I want to monitor the switch port, like these two ports, right? So in the span, see, the source port means the port which I want to analyze, monitor, and the destination port means the port which is connected with the server where I want to store the copy of traffic is located at same switch. So this type of span is called local span, correct? So here we'll define directly monitor, session, then session number, then source, interface ID, and then destination interface, and then interface ID. But in my scenario, see, I want to analyze these two ports, right? So these two ports are source port. Again, these two ports are source port. I want to analyze this port, and this port is what? This port is the destination port. So guys, on switch number 1, destination port belongs to different switch. So in that scenario, you have to configure span VLAN. You have to configure span VLAN. For that, simply you can run command VLAN, then 100, let's say, and after that I can say remote span. Remote span. Once I will hit enter, this VLAN will become span VLAN, right? So here I can try this command. VLAN 100, and then I am saying remote. See, I'm not able to run this command. Definitely this switch is actually not supporting the feature, this feature, so I have to use another switch here. Okay, leave it for now. I will make one separate video for span configuration. Apart from the span, is there anything else that we can configure? We will configure the VLAN hopping. So on the trunk link on interface E0/0, I can say, see, if you want to perform tagging for the native VLAN as well, like my native VLAN on the trunk link is switch port, trunk, and native VLAN. So native VLAN is 1. By default, native VLAN is 1. Even you can change the native VLAN, and you should change for the security purpose. And guys, by default, switches will not add tag for the native VLAN, right? So attacker can attack in your network with the help of native VLAN. That's why we are using VLAN hopping. And to configure the VLAN hopping, here I can say VLAN and then dot. Why I'm not able to run this command? VLAN VLAN 1 and VLAN. Okay, actually we are not able to run these commands over here like VLAN hopping command and span command. So I will make a small video for these two topics. Rest all thing you can configure over here. Okay, then only two things is pending on access layer switch 1. You can configure the span and you can configure the VLAN hopping. Now guys, let me take you to access layer switch 2. On access layer switch 2, I'm going to perform same configuration like access layer switch 1. So first of all, let me change the host name a switch 2, and then I am going to create VLAN 20 name. Let's say here name is finance, right? Then I can add port interfaces in this VLAN. So interface range E0/0/1 2 3, right? All ports will be in VLAN 20. So interface range E0/1 2 3. I'm saying switch port access VLAN 20. Done. And switch port mode access. Now I need to configure E0/0 as trunk. So interface E0/0 switch port trunk encapsulation.1q, and after that switch port mode trunk. Done guys. Now we can verify it. So VLAN brief. So you can see in VLAN 20 we have some interfaces, and so interface trunk. So 0/0 is configured as now trunk. Even we can verify it on access layer switch 1. So interface trunk. So you can see this interface is configured as trunk. Done. Now here on switch number 2 I need to configure port security. So to configure port security, I can say interface range E0/1 2 again 3, and switch port security to enable port security, and then switch port security maximum again I am saying 1, and switch port security MAC address I am saying ST key for the dynamic learning, and switch port security violation here also I am saying set down. Done. So the port security configuration is also done on both access layer switches. Now guys, let me access distribution layer switch, and let me perform some basic configuration on distribution layer switch. Now we are trying to perform inter VLAN routing so that these two VLAN or these two floors or these two different types of traffic can communicate with each other. So host name I am going to say switch only, or I can say D switch, distribution layer switch. Now guys, here I need to configure these two port as trunk port. These two link, this port and this port should be the trunk port, right? So first of all, let me configure these two ports as trunk. Interface range E0/1 to 2, and say switch port trunk encapsulation. As you know, trunk encapsulation must match, right? So encapsulation protocol is .1q over here as well, and then switch port mode trunk, right? Do so interface trunk. Now you can see both interfaces are configured as trunk. But guys, allowed VLAN, see all VLANs are allowed on this trunk link, right? So again, this is not good for the security. So I can say switch port trunk allowed VLAN, and I am going to allow only VLAN 10 and 20. 10 and 20 like this, right? So now, so interface trunk, you can see now only VLAN 10 and 20 are allowed. So a spanning tree summary, which type of a spanning tree protocol is running? PBST. So as you know, in PBST, whenever change will occur, it needs 30 seconds, right, or 50 seconds to come in forwarding state. So here I am going to change the spanning tree protocol as well. Spanning tree mode, rapid PBST, right? On access layer switches as well, I need to change the spanning tree mode. Access layer switch 1, spanning tree mode, rapid PBST. And here I am going to enable port fast as well, because port fast should be enabled on all the S port. So spanning tree for VLAN 1, for VLAN 10, and I am saying port fast. I cannot run command like this. Port fast. So for all VLAN, it will enable the port fast. Simply say default. Done. So it is giving the warning, but it have enabled the port fast. Now switch number 2, access layer switch 2. Here also a spanning tree mode RPBST and a spanning tree port fast default. Right now, guys, you can try even that your port fast is working fine or not. Do so a spanning tree. So in the spanning tree in VLAN 20, you can see both ports, all ports are there, and their states are listening. States are listening for VLAN 20. For VLAN 20, it is in forwarding. Let me try to down E0/1, say shutdown and no shutdown, and let me check it is coming in forwarding state quickly or not. Yes, now you can see 0/1 is in forwarding state. So port shutdown, port has gone, and say no shutdown, and now you can see port is in forwarding state, right? So now it will not take 30 seconds to come in forwarding state. So I have enabled the port fast feature, correct? Now question is, can these PCs get IP address from the DHCP? Let me try. From PC1 I am saying IP DHCP. Nope. Can this PC3, which is connected with same switch where DHCP server is connected, can this PC get IP address, IP DHCP? So guys, yes, you can see this PC is able to get IP address from DHCP, and this PC have got the IP address which is 192.168.2.1, and the gateway IP address is the last IP address from the subnet. In the same way, PC4 can also get IP address from DHCP. IP DHCP, that means DHCP is working fine. Now see, this machine have also got the IP address 2.2. Now why these PCs, like PCs on switch number 1, are not able to get IP address from the DHCP server? Reason, guys, see, when I am trying to assign IP address on PC1 from the DHCP server, what will happen? First it will generate the discover message, broadcast message. It will forward to this switch. This switch will forward it from the trunk link, and it will add the tag number, right? Whenever it will forward traffic on trunk, it will add tag 10 for VLAN 10. And this distribution layer switch will receive it on this interface. This interface is also trunk. So it will check the tag number. Tag value is 10. First of all, this switch is not going to process it. The reason, VLAN 10 is not available in the VLAN database, right? So if switch is receiving a frame with tag value 10, and tag value 10 means is a traffic of VLAN 10. It is a traffic of VLAN 10, and if VLAN 10 is not there in the VLAN database, then switch will discard it, right? So first of all, we need to create VLAN 10 and 20 on this switch, on distribution layer switch, right? These are the troubleshooting. Sometime you might have seen this type of issue in real time if you are the experienced one. So here I am saying show VLAN brief, and you can see only VLAN 1 is there, right? VLAN 10 and 20 is not there. Let me create VLAN 10 and name to HR. Then VLAN 20 and name to this VLAN as finance. Done. Now so VLAN brief. Now you can see VLAN 10 and 20 is there. Now can PC1 get IP address from the DHCP server? Let me try. Nope. Still PC1 is not able to get IP address. Guys, now the reason is this PC is in different network, right? This PC is in different network. DHCP server is in different network. So to forward traffic in different network, what we need? We need default gateway, right? So we need to create SVI on this distribution layer switch. Let me access distribution layer switch. Here is the distribution layer switch here, and let me create the SVI here. So guys, I need two SVI here, one for VLAN 10, one for VLAN 20. SVI means switch virtual interface. So interface VLAN 10, say no shutdown, and then IP address. Here IP address will be 192.168.1. Last IP address from the subnet 254.255.255.255.0. Then interface VLAN 20, again say no shut, and IP address 192.168.2.254.255.255.255.0. You can check the routing table of this switch. So IP route, this is multi-layer switch, and you can see it have installed both network in their routing table, correct? And from this switch you can ping to PC3. Ping 192.168.2.1 was the IP address, and this ping should work. You can see ping is working. Even I can ping PC4 2.2. This ping will also work. You can see ping is working, right? But guys, these PCs are not able to get IP address from DHCP server, right? Still PC1 cannot get IP DHCP. So what is happening now? Now guys, issue is, see, on this distribution layer switch, there are two broadcast domain, right? One is VLAN 10, another one is VLAN 20, right? So switch is receiving discover message of PC1, which is the broadcast on which interface? On VLAN 10 interface. So it will not forward that broadcast message from VLAN 20 interface, correct? It will not forward, because this is different broadcast domain, this is different broadcast domain. So we need to configure helper address here, right? I have to tell to this machine that, bro, whenever you will receive the discover broadcast message, do one thing, convert it into unicast and then forward to this server, right? Now the requirement is server should be reachable from the switch. So you can try to ping the server from the switch. Server IP address is, guys, 192.168.2.100, and you can see I'm able to ping the server, right? Server is reachable. So I can configure the helper address. To configure the helper address, simply go to interface VLAN 10 and say IP helper address, and IP address of DHCP server is 192.168.2.100. Done. Now PC1 and PC2 can get IP address from the DHCP server. Let me try. IP DHCP. Still not getting IP. Wait, we need to troubleshoot it. Let me try once again. PC1. I'm going to close the console of PC4. Will have access of one PC on both switch. PC1. See, I'm not able to get IP address. So how to troubleshoot? So IP all. Let me show you the MAC address of this machine. So guys, MAC address of this machine is this one. In last it's 6802. 6802. Let me take you to access layer switch 1 and let me find that this switch is learning this MAC address or not. This MAC address, right? So how to find that? Here I can run command show MAC address table and then MAC address. MAC address table, and then we can say dynamic here, and after that I can say address. For this address, show me the entry. So there is no any entry. That means this switch is not learning MAC address of PC1. Now why? See, let me try to generate discover message again, and now again I am going to check the MAC address table. No, not able to learn MAC address. So if this switch is not able to learn the MAC address of PC1, that means there is some issue. So VLAN brief, right? See guys, 0/1 interface is in which VLAN? Is in VLAN number 10. That is the correct, right? This interface is in correct VLAN. So interface status. So interface is also connected and part of VLAN 10, right? So MAC address table and aging time for VLAN 10, MAC aging time is 100 seconds. That is not a issue. So interface trunk, on the trunk link all the VLANs are allowed. Later we will allow only VLAN 10 and 20. It should learn the MAC address. Switch 1. So MAC address table, it is learning one MAC address over here. Fine, but why then I am not able to open the MAC address table with the help of address? This is error then, right? Actually this switch is learning MAC address, right? We are able to see the MAC address of PC in MAC address table. Okay, the reason is guys here, because of port security type is now static. Because of port security type became static, because it have binded this MAC address with this port, right? Because I have configured the port security. So run interface is 0/1 because of the configuration. I had said sticky, right? So it have picked the MAC address dynamically and it have bind the. So now how we can troubleshoot it? Now we can say so MAC address table, and then we can say static, and after that we can put the MAC address. MAC address of PC is here. Static and then entry. Sorry, before that we have to say address. Done. Now you can see I'm able to see the MAC address, correct? In the same way guys, I have to check distribution layer switch, like distribution layer switch is learning MAC address of PC1 or not. So I have already copied the MAC address, and again I am going to say IP DSCP, and let me take you to distribution layer switch. Here I am going to say so MAC address table, here dynamic, and then address, and then this address. So this device is also learning MAC address of PC1 on this port, on 0/2 port. Now let me take you to switch 2, access layer switch 2. On access layer switch 2, access layer switch 2 should learn MAC address of PC1 on E0/0. So let me check. So MAC address table, address, and where is the MAC address? I can say like this, address, right? See, there is no any port available. So MAC address table, guys, there is one MAC address on 0/0 port, and this is the MAC address of gateway, right? See, the VLAN is 20. So now question is, why switch 2 is not able to learn the MAC address of PC1? Why switch is not learning MAC address of PC1? So VLAN brief, VLAN 10 should be there in the VLAN database, which is not available, right? So same thing this time, this switch is doing, this switch is dropping the traffic. The reason guys, when switch 2 will receive the discover message, right, over here there will be one tag, in tag value will be 10, right? Like when distribution layer switch will forward the traffic on the trunk link, it will add the tag of VLAN 10. On switch 2 will receive it, it will check the tag value is 10, that means this is traffic of VLAN 10, and VLAN 10 is not available in the VLAN database, so it is dropping the traffic, right? So let me create VLAN 10 here. So to create VLAN 10, simply I can run command VLAN 10 and then I can define the name, which is the HR. Done. All done. Now again you can request for IP address to DHCP, and before that let me copy the MAC address and see till now. So MAC address and address, there is no any entry available for this MAC address. Now IP DHCP, and this time again I am going to check the table. This time you can see this machine is learning MAC address of PC1, right? So let me check this machine is able to get IP address from DHCP server or not. Now still not able to get IP address, right? Now what is the issue? Now guys, I think VLAN 20 is not there in the VLAN database of switch 1. So VLAN brief, yes, you can see VLAN 20 is not there, right? So what is happening this time? PC is generating discover message. It will forward to this switch will forward to server will generate reply, right? It will forward to this switch will generate offer message to this switch, and when this switch will forward the offer message from the trunk link, it will add the tag of VLAN 20, and on switch 1 will receive the offer message. It will check tag value is 20, but VLAN 20 is not there in the database, so it will drop the traffic, right? So let me create VLAN 20 here on access layer switch 1, config t and VLAN 20 and name finance. Done. Now everything is fine. PC1 should get IP address from the DHCP server, and finally let me try to configure IP here. Still PC1 is not able to get IP address. Again now we need to troubleshoot what is the issue over here. Can't find DHCP, right? Now what we can do here, see on the DHCP server I can debug the DHCP to check that this machine is sending offer message or not. Debug, or you can do one more thing, like you can check the MAC address of DHCP server on your access layer switch 1, because guys access layer switch 1 should learn MAC address of this server on this port, correct? So we can verify that this switch is learning MAC address of server or not. So first we need MAC address of server. For that I can say so interface f0/0 and then include BIA, right? So here is the MAC address of the server. Let me find this MAC address in the MAC address table of switch 1. So MAC address and then address and this address. No, it is not learning MAC address of the server IP DHCP. No, there is nothing, right? Even so MAC address, and then I can say interface, let's say E0/0. So on E0/0 it is learning only one MAC address, this one, which is the MAC address of I think default gateway, like my switch 1, this distribution layer switch VLAN 20 MAC address. Even we can verify that here. I can say so interface VLAN 20 and include BIA. So yes, you can see this is the MAC address of VLAN 20 interface on your switch. Question: why switch is not learning MAC address of default gateway? They are on default gateway, means VLAN 10 interface. So guys, so IP interface brief exclude unassign VLAN 10. IP is there. IP is there. So let me try once again, and I'm going to check the MAC address table. No, this switch is not learning MAC address of their on default gateway, right? Still there is issue. So now how to troubleshoot it? Why it is not learning MAC address of their default gateway? I mean, like access layer switch 1 is not learning MAC address of VLAN 10. Correct? So guys, to troubleshoot, definitely we have to check what trunk. So interface trunk. Like this can be because of, encapsulation mismatch or the native VLAN mismatch. But you can see everything is fine. But the allowed VLAN is different. Allowed VLAN on access layer switch 1 is all, and allowed VLAN on interface. So interface trunk. Allowed VLAN on this is 10 and 20. Let me allow only VLAN 10 and 20 over here as well. Interface E 0/0. Switch port trunk allowed VLAN 10 and 20. Right now, let me try to find the MAC address. Access layer switch 1. So MAC address. Show MAC address and then interface E 0/0. Still it is not learning. Still it is not learning the MAC address of VLAN 10 interface. So interface VLAN 10 include BIA. MAC address of both interfaces same. Actually for the both SVI interface it is using same MAC address. VLAN 10 also, and for VLAN 20 also you can see we have the same MAC address, right? Okay, that is not a problem. This is in virtual, but the question is why this PC is not able to get IP address from the DHCP server. So let me do one thing, guys. On the DHCP server I am going to debug DHCP, debug IP DHCP, and then server, and then events. Correct? Now let me try to get IP again. Yes, DHCP server is generating the offer message as well, right? DHCP sending notification of discover, that is the offer message with that means the server is not able to send this offer message to PC1. Now again we have to troubleshoot the issue. So on distribution layer switch 1 I'm going to check so MAC address table, and guys in the MAC address table see on both port, on 0/1 port we have one MAC address. This is the MAC address of PC1 and this is the MAC address of server. So interface F0/0 include BIA. Yeah, this is the MAC address of server. So this distribution layer switch is learning MAC address of both device, server as well as PC1, but access layer switch 1 is not learning MAC address of this their default gateway like VLAN 10 interface. So run interface VLAN 10, IP helper address is correct, and ping 192.168.2.100. yeah, I'm able to ping this IP address as well. Then what is the issue? So interface trunk (0/1 and 0/2 both interfaces are configured as trunk. Just wait, let me troubleshoot it. So interface trunk E0/0 is trunk, and the encapsulation protocol is .1q. Here also encapsulation protocol is .1q. native VLAN is 1, mode is on, everything looks fine here. Let me do one thing for the troubleshooting. Just I'm going to configure one static IP here, 192.168.1.1/24, and gateway 192.168.1.254, and let me ping the gateway 192.168.1.254, and I am able to ping the gateway. Now access their switch 1. So MAC address table, yes, now it is learning MAC address of their default gateway as well, right? IP DHCP. Now it should get the IP address from the DHCP server, but I have to troubleshoot this one. What is the issue here? On switch 2, so interface trunk 0/0 is configured as trunk, allowed VLAN is out. Let me only allow VLAN 10 and 20 here also. Switch port trunk, allowed VLAN 10 and 20 only. Let me try to get IP from PC2, IP DHCP. Even server is sending the offer message. Okay, from PC1. So IP over here is 1.1. Let me ping the DHCP server 192.168.2.100. Oh, I have got the issue, guys. Issue is default gateway. I have not configured the default gateway IP address on the server. This is the reason. So let me fix it. On the server, default gateway IP address is required, right? On all. This was the minor issue here, right? No problem. Say no IP routing, and here IP default gateway. Default gateway IP address will be 192.168.2.254. Now this PC can go get IP address from the DHCP. Let me show you IP DHCP. Yeah, you can see now it's working, and it have got the IP address which is .1. Fine, guys. Now PC1 is able to get IP address from the server, and you can see I'm able to ping the server as well. PC2, in the same way, PC2 can also get IP address from the DHCP server, IP DHCP. So PC2 have also got the IP address from DHCP server. Now guys, everything is working fine, and you can verify the connectivity between VLAN 10 and VLAN 20. Like from PC1, I can ping to PC3. So as you know, PC3 IP address is 192.168.2.1, 192.168.2.1, and you can see ping is working. Ping will work. Just wait. If it is not working, then I should verify the IP address on PC3. So IP 2.1, correct? So I'm pinging to right IP address. Why ping is not working? So IP, here the default gateway IP address is DHCP. Default gateway IP address is fine, 192.168.1.254. And on PC3, what is the default gateway IP address? 2.254, 1.254. That is correct. Then ping should work. Let me ping again. The ping is not working. Still I am not able to ping PC3 from PC1. Let me try to ping PC4.2. No, I am not able to ping. So these PCs are still not able to communicate with each other. From PC3, I'm going to ping their gateway 192.168.2.254 and able to ping their gateway. This machine is also able to ping their gateway. Yeah, both PCs are able to ping their gateway, but why they are not able to ping each other? 1.1. Yeah, from PC3 I am able to ping PC1. Now from PC1 also I am going to ping 192.168.2.1, and you can see ping is working. It was taking some time. This is just because of simulation, right? So everything is fine, guys. Both LAN are able to communicate with each other, correct? Now guys, I'm going to configure routing between distribution layer switch and router 1, right? Distribution layer switch 1 and router 1. Even we can configure the static routing, or we can configure the dynamic routing protocol. So as we have here two devices only, right? But in your scenario there can be multiple devices, so you can use the dynamic routing protocol. Let me configure the dynamic routing protocol here. Let's say OSPF. So to configure OSPF, router OSPF 1, and then say router ID 1.1.1, and after that I am going to enable OSPF on interface range is 0/0, then interface VLAN 10 and interface VLAN 20. Say IP OSPF, IP OSPF 1 area 0. I am not able to run this command. I have to run network command here only. Router OSPF 1, and then I can use network command here. Guys, sometime the on the interface, this is just because of simulation we are not able to run OSPF on interface basis. So here I can run network 192.168.1.0 wildcard mask 0.0.0.255, and then I can say area 0. In the same way I can advertise 2.0 network, and then I can advertise this 10 subnet, the 10.1.1.0, 10.1.1.0, which I will configure here, right, between switch and router. So I have advertised it. Now I need to configure IP on E0/0, say no switch port first, and then IP address. Maybe the command was it was not taking the command because of switch port. Now you can see the command is working, IP OSPF, right? So here IP address is going to be 10.1.1.1 255.255.255.0. Done. Now do so IP OSPF interface brief. You can see OSPF is enabled on these all interfaces, correct? And we are going to change the network type on E0/0 IP OSPF network point to point. Done. Now let me take you to router 1 R1. So let me access router 1. Router 1, and on router 1 first let me configure IP on LAN interface F0/0, say no set, and IP address 10.1.1.2 255.255.255.0, and IP OSPF network, here network type should be point to point. Then I need to enable OSPF, so router OSPF 1, and router ID I am saying 2.2.2.2, and guys let me enable OSPF on F0/0 IP OSPF 1 area 0. Now I am expecting OSPF neighborship. Till then I am going to change the host name R1. And you can see now we have OSPF neighborship here, correct? So IP OSPF neighbor. Neighbor is in full state, and as network type is point to point, there is no DR and BDR. So IP OSPF interface brief, you can verify that OSPF is running on this port. That means router should have both LAN network, so IP route OSPF, and you can see it is learning both LAN network, correct? 192.168.1.0 as well as 2.0. Fine. Now even you can try to ping router 1 from PC1, like from PC1 am I able to ping router 1 or not? So ping guys 10.1.1.1, sorry 2 is the IP address of router 1, and you can see ping is working. I am able to ping router 1 as well, right? Now we need to configure edge router, like link WAN links on the edge router. So let me take you to R1 and let me configure IP on WAN link first. So interface F1/0, and guys the problem is video length is getting lengthy. Say no such. I can divide this video into two parts. IP address, first let me configure the WAN link here. 100.1.1. Here what IP address I will use is first IP address 1, and 255.255.255.240. Done. Now I can try to ping the internet router 100.1.1.14 was the IP address of internet router, and you can see ping is working, right? I am able to ping ISP1 router. Now let me configure second WAN link, which is F2/0. Say no set and IP address. Again I will configure first IP address from this subnet on router, which is 100.1.1.17. 255.255.240, right? And do ping 100.1.1. Last IP address was 30, so let me ping the 30, and you can see ping is working. That means both ISPs are reachable from this edge router from R1. Can I ping 8.8.8? No, you cannot ping 8.8.8 because default route is not there, right? So now guys, let me configure default route and see how I will configure the default route. ISP1, for now let's say ISP1 is my primary ISP and ISP2 is my secondary ISP, right? For now just I am configuring the scenario so that my end users can access internet, right? And later we'll see the BGP configuration here. So on R1 I need to configure two default route, right? As I told you, this is my primary ISP. Let me write here. Primary ISP. Primary, and here I am saying backup. Fine. So I need to configure two default route, IP route 0.0.0, 0.0.0, and exit interface is F1/0, and next hop IP address is 100.1.1. Guys, last IP address is running on ISP side, means 14. Done. See here I have configured one default route with default AD value. Actually we need to configure conditional default route here, right? So another default route is going to be like this. F2/0, and then next hop IP address 100.1.1.30, and I'm going to add AD value over here, right? Let's say 10. So it will use the default AD value default route first. If that is not available, then it will use this one. And with this default route I am going to use track, because I am going to track the ISP1 as well, right? Like until unless ISP1 is up, then it will be forwarding traffic to what ISP1, right? So once track will goes down, actually here we don't need to use the track should be applied on track should be applied with the default route, right? Like see, do so run section IP route. So in the running configuration we have two default route, and here we should add the track, right? So we need to track 8.8.8 via ISP1, and if the track is down, right, then it will use this default route. This should be my requirement. This is my requirement actually, correct? So for now this router is using this default route, do so IP route, and we can say include 0.0.0. So you can see it is using this default route towards ISP1, because here we have what higher ED value, correct guys? So now guys, I need to create one track. See, for now I can ping 8.8.8, ping 8.8.8.8, and see ping is working. I am able to ping 8.8.8 via ISP1. Even you can trace route 8.8.8.8 and see numeric, right? So you can see traffic is going to 14, means ISP1. The reason guys, so IP route in the routing table default route is toward ISP1, right? So I am going to use track with this default route. Until and unless track will be up, it will be using this default route. If track is down, it will be not using this route. And if it will not using this route, then it will install which route in the routing table? Do so run section IP route. It will use this one, then this one, correct? So let me apply the track, do so run section IP route. I'm going to remove this default route because I'm going to call track with this default route, say no, and again say IP route 0.0.0 fast ethernet 1/0. This is the next hop, and I am saying track, and let's say track number is 1. Fine. Now do so track. Is there any track guys? No. So now we need to create the track. So let's say track, and then track object number 1, and after that I'm going to track. You can see track 1 interface. You can track ISP1, right, the line protocol of fast ethernet 1/0, or you can track 8.8.8, right? So guys, if I will track this port, this port or this link, then what will happen? If the service will goes down, let's say the server is not working, 8.8.8 is down, then also my router will be forwarding traffic towards ISP1. So to track 8.8.8, what we can do? We can use SLA, right? Service level agreement. So here I am saying, let's say IP SLA. I'm going to use IP SLA. So the number of IP SLA is, let's say again 1, right? Like this, I can say reachability. So this track is using IP SLA 1, right, for the reachability. Now there is no IP SLA, so I need to create one IP SLA. Now do so track, do so track. So you can see we have one track, but this track is down. Why this track is down? Because in the track I am using IP SLA, and that IP SLA is down. Do so IP SLA. There is monitor IP SLA, and we can check the SLA configuration here. Let's say summary, or do so run, you can say section SLA. So there is nothing. IP SLA is not enabled now. Now I need to configure SLA. So say IP SLA number 1, which I am using here. Number was 1 or 10? Yes, 1 only, right? So this is nothing but the entry number of SLA, which is 1. And guys, after that, see, in this IP SLA, I am going to use ICMP protocol, right? Like I want that router 1 should keep sending ICMP to 8.8.8. So I will say ICMP echo, means ICMP echo request to whom? To 8.8.8, right? Then from which interface? From source interface. Which interface? Fast Ethernet 1/0. From this interface, it will be keep pinging 8.8.8. Even you can ignore it, the source interface like this you can configure. ICMP echo 8.8.8. It will be pinging 8.8.8. But this time, what will happen? If this interface will goes down, then also 8.8.8 will be reachable from this interface f2/0, right? So your track will not goes down, right? So we should not use like this. Say no IPS 1, then IPSLA 1, then say ICMP echo to 8.8.8.8, and after that interface 8.8.8, and then source interface I can say fast Ethernet 1/0 like this, right? And here you can define the threshold, timeout, these values under the SLA, like frequency, how frequently you want to send the ICMP message. Now guys, I have created the track, I have created the SLA. Do so track. Still track is down, right? And even we can debug it to check that router is sending ICMP packet to 8.8.8 or not. So debug IP ICMP, right? So, and you can see it is not sending any. It is not sending any ICMP message. So actually we need to schedule the track, right? We have created the track, but we have, sorry, SLA, but we have not scheduled it. So we need to now schedule the SLA. We have to start the SLA. So IP SLA schedule, right? And then guys, SLA number is 1. After that, when you want to schedule like a start time, we can say now. Then we can define the life, let's say forever, right? Like this, right? Now it will start sending ICMP echo request message to 8.8.8 from fast Ethernet 1/0, right? From fast Ethernet 1/0. So IP SLA summary. Here you can see the configuration, right? It is sending ICMP echo request message. Which type of SLA is there? This is ICMP SLA, right? And for which IP address, for which host, for 8.8.8, right? And these are the default configuration for the timers. Done. Debug IP ICMP, and so track is down. So IP route include 0.0.0. So which route is there in the routing table? Default route is this one, right? 0.0.0. So what is happening here, guys? Let me do one thing here. Just for a moment, I am going to do so run section IP route. So see what is the issue now? There are two default route, right? So router 1 is trying to ping 8.8.8, but 8.8.8 is not reachable. Why 8.8.8 is not reachable? Because of route. Do so IP route. In the routing table, default route is available from this interface, from fast Ethernet 1/0. Means from fast Ethernet, sorry, 2/0. From fast Ethernet 1/0, it cannot ping 8.8.8. See, if I am saying ping 8.8.8, do ping 8.8.8.8, and source interface fast Ethernet 1/0. Will ping work? No, this ping will not work. The reason default route is not available over here. So guys, for a moment, I can configure one static route here for 8.8.8. Right, I can configure a static route here for 8.8.8, or for a moment I can down this interface 2/0, say shut down. Once I will down this interface, do so IP route. What will happen? It have removed the default route from the routing table and do so IP do so run section IP route. Say no set. This is I have no set this. Just wait for some time. I got the issue why it is actually this router is not able to ping 8.8.8 via ISP1. So I can configure one route IP route. Let's say 8.8.8 255.255.255.255 and I'm saying fast Ethernet 1/0. From this interface it will be keep pinging to 8.8.8. Do so IP route. Now 8.8.8 is there, right? And exit interface is this one. So do so IP route. Default route is still there toward which ISP? Yeah, toward ISP2. Now see guys, it is now keep pinging to 8.8.8 and this is why your track is up now. And once your track will up, it will change the next like default route. See, it is keep pinging to 8.8.8 and it will be pinging, right? And now so IP route. So as track is up, it have installed default route towards ISP1. It have installed default route towards ISP1. The reason track is up. Include IP route. Sorry. Include 0.0.0. You can see default route is via ISP1, right guys? Correct. So trace route 8.8.8.8 and source, not source, only 8.8.8. Yeah, I can say numeric. You can see traffic is going via ISP1. Traffic is going via ISP1. Now when ISP1 will goes down, let me access ISP1 and let me down the interface. See, interface F0/0 and for a moment I am saying shutdown. On this interface will goes down, what will happen? Track will goes down here, right? Because router cannot ping 8.8.8. ICMP, see, your track is now down. And once your track will goes down, what will happen? It will install default route towards ISP2. So IP route include 0.0.0. So now it have installed default route towards ISP2, right? So now I can trace route 8.8.8.8 and numeric. Now you can see my traffic is going via ISP2. Just wait for a minute. Oh, I think a route default one static route is there. Static route is there for 8.8.8. Yes, this is the reason. Like 8.8.8, there can be any another server, and for that server, guys, for on both ISP, ISP1 and ISP2, I am going to get one more loopback. Interface loopback 1, IP address 1.1.1. 255.255.255.255. Let's say it's another server. On ISP2 also interface loopback to IP address 1.1.1 255.255.255.255. Correct. So where is the ISP1? Here. Oh, I have configure it on loopback 1 interface. On loopback 1 it should be 8.8.8 only, and interface loopback 2, here I am going to add 1.1.1 255.255.255.255. Done. Save the configuration. Right, on ISP2 also I am going to write the configuration. Now we have two services, right? Let's say 8.8.8 is not your main service. Your main service is 1.1.1.1. on the internet. On the internet there are two services, 1.1.1 and 8.8.8. Now let me take you to router 1 and see trace route 1.1.1.1 and numeric. Guys, traffic is going via ISP2. Why traffic is going via ISP2? Because ISP1 is down, right? Once ISP1 will come up, let me run noset command on F0/0, interface F0/0, say noset. Once ISP1 will come up, what will happen? Track will come up, and after that, if you will trace route, just wait for some time. Yeah, still traffic is going via ISP2. So track. So to reduce this time, we can configure the timer here. Still track is down. Wait for some time. Soon this track will come up. Ping 8.8.8 and source fast Ethernet 1/0. From this interface 8.8.8 should be reachable. Yeah, it's reachable. So my track will come up. Yeah, now you can see your track is up. Here the log message, and on track will come up. So IP route include 0.0.0. It will shift the default route towards ISP1. So if you will trace route now again 1.1.1.1 and say numeric, you can see traffic is going via ISP1, right? And again guys, when ISP1 will goes down, again I am going to down ISP1. So trace route 1.1.1 numeric. Again when ISP1 will goes down, what will happen? Track will goes down. Once track will goes down, it will shift the default route. It will install default route towards ISP2. So track, it is taking some time. This is just because of simulation. You can see track is still up, and even we can change the threshold value. IP SLA 1. IP, now you can see the track is down. Now track is down. So let me trace route. You can see traffic is going via ISP2 now, right? Now guys, the video length is getting lengthy, right? So what I will do, I will divide this topology, this complete configuration into two parts. This is first part, and in second part we'll see the rest configuration, right, between edge router and ISP. That's all for today guys. If you have learned something from this video, please hit on like button. If you have any question, query, concern, please let me know in the comment section. And if these types of videos are helpful for you, if you are learning something from these types of video, please hit on like button. Please let me know in the comment section guys. Just type yes in the comment section. It will motivate me to make more videos like this, right? So your yes is very important for more videos like this. Done. So just I'm not saying to write large sentence in the comment section. Just type yes. Once you will type yes, I will get to know these types of videos are helpful for you and you guys are learning it. Okay, thanks for watching guys. That's all for today. Let's meet in the part 2 soon. Maybe tomorrow we'll create part 2. Bye.